Kia ora. Let's look at another example of drawing ray diagrams to find the position of the virtual image. So this is also from a 90938 past exam paper. And what they're basically saying is if you're on a boat and you're looking down and you see this box resting in the water underneath, where will you see this box and what describe the box in terms of the image? Is it upright, inverted, enlarged, smaller, and so on? So the first thing I like doing is drawing a guiding line from some point on the box. I'm going to choose this corner, and so this sort of helps me and I go, okay, I know now I, that light won't travel in straight lines because I'm going from water to air. So we know that the light ray, because it goes at a different speed, will bend. So I need to draw a line slightly to the right. I can't do it to the left because then it's going to bend to over here. It must reach the person's face or eye. So once I've reached the surface, now the light is going to bend and I need to work out by how much. So I draw always the normal, and the normal is always at 90 degrees. Now the angle of incidence is this one over here between the normal and the ray, not between the surface and the ray. It's always between the normal and the ray. Because I'm going from more optically dense to less optically dense, the angle of refraction must be bigger than the angle of incidence. So here's my angle of incidence, and there's my angle of refraction. So I make this angle bigger. Okay, now I repeat, and I need to do that second ray because I need to know more or less where I'm going to find the image, and one line won't be enough. So I draw a second ray just slightly to the right of that again. You don't want to make it too far to the right because that gets awkward. Just make two very close together. Again, draw on the normal so that our angle of incidence is always smaller than our angle of refraction. This must be bigger. And notice I'm not trying to hit an eye this time because the eye is much too small, so I'm just doing in the general direction of the face. But notice that these will converge, they're not parallel lines. If you draw parallel lines here, you're not going to ever get an image. So they must diverge a bit. And now, because we see light is traveling in straight lines, because that's what our brain tells us, we extend these backwards. So this corner of the box now will fit over here, and it will now be parallel with the surface. So we're going to draw that image over here. It'll be bigger because it is closer to the person. It will be upright because this is parallel to the surface, and it will also be virtual. Somebody could swim here and wave their hands here, and it's not going to go through any object over here because all of these lines are not real. Those are not real light rays that we can disrupt. The light rays are actually coming from over here. So hopefully that shows another example of how we can draw light rays or use ray diagrams to find the position of the virtual image. Kia ora.